Hello, chemistry students. This is Dr. Bower-Phipps, and I'm going to walk you through how to find the answers for our Homework 3 Balancing Chemical Reactions Level 2. There were 3 different tricks that we looked at in this problem set, so let's begin. Problem number 1, you had a double replacement reaction. The first step, again, is to write down all of your uh, elements in here. Remember, the trick that we're using here is that if it has a parentheses around it, or if we can find it on the back of our periodic table, it's a family. So count it as a family here. I've written down all of our elements and families here, right? We have Al and SO4 and Ca and OH. And then I went ahead and counted them. There are 2 Als, 3 SO4s. There is 1 Ca and 2 OHs. On the left-hand side, 1 Al, 3 OHs, 1 Ca, 1 SO4. Remember that 4 is part of its name, so we don't count it. Now we balance. 2 Als on the left, 1 on the right, so I need to put 2 on the right-hand side. And that changes my Als, right? It's no longer 1, now it's 2 Als, and 2 times 3 gives me 6 OHs now on the right. Now let's fix the SO4s. If I have 3 on the left and 1 on the right, I need to have 3 on the right as well. So I put a 3 in the top there. It multiplies through everything. 3 times 1 Ca gives me 3 Cas. 3 times 1 SO4. Remember that 4 is part of its name. So 3 times 1 gives me 3. Good job, math. All right. 2 and 2 Als. 3 and 3 SO4s, 3 and 1. Oh, we need 3 Cas on this side also, so I put a 3 in the top here. It multiplies through 3 times 1 Ca. Now I have 3 Cas. 3 times 2 gives me 6 OHs. And then we're done. If you want to, you can put a 1 there. You don't have to. Problem number 2. Looks like another double replacement. So we're going to use our families trick. But when we're counting them, so I've already put them down there and already counted on the left-hand side. But when we're counting on the right, I can't even see the OH on the right. Remember, this is where it's hiding. So I'm going to make my H2O formula look differently so that I can see where that H and OH are, right? There's my H2, 2 H's, 1 O in that family. So now I can count 1 OH and 1 H on the right. Let's balance our FEs. First I put a 2 on the left so that now I have 2 times 1 is 2 FEs. 2 times 3 now gives me 6 OHs. All right, my FE's balanced now. Now I want to make sure that the 6 and 1 balance. So I need 6 on the right-hand side as well. So I put a big 6 on the top there. It multiplies through. 6 times 1 gives me 6 H's now. And 6 times 1 gives me 6 OHs now. All right, my FEs are balanced. My OHs are balanced. Now let's make my H's balanced. I have 6 on the right. I need 6 on the left. So because there's a little 2 there, 2 times what gives me 6? 2 times 3. Yay, math! So 3 times 2 gives me 6 H's, but remember it also multiplies through to the SO4s. There's no parentheses around it, but that 4 is part of its name. So 3 times 1 SO4 is 3 SO4s. Okay. And that took care of my SO4s. Yay! If you want, you can put a 1 here to show that we didn't have to change that one at all. All right, number 3. Now we have one of the combustion reactions. We're burning. Remember, these ones are harder because we have O's in 2 different places on the right. So I have C's, H, and O's. I've counted 3 C's, 6 H's, 2 O's on the left, 1 C, 2 H's, but I'm counting, remember, 2 oxygens here plus 1 oxygen here. So that means 2 plus 1 equals 3 oxygens on the right. Okay, 3 oxygens. Let's balance our carbons first. 3 and 1. So I'm going to put a 3 here to make that 3 total carbons, right? 3 times 1 is 3, but it changes my oxygens. 3 times 2. Now this little one isn't 2 anymore. It's actually 3 times 2 is 6. But we still have 1 over here. So our new total of oxygens is 6 plus 1, or 7. Carbons are taken care of. Now let's go to my hydrogens. I have 6. I need 6. So 2, right? I'm multiplying this 2 times 3. 2 times 3 gives me 6 hydrogens now. But remember, this 3 also multiplies by that 1 oxygen. So I don't have 1 oxygen anymore on this side. Now I have 3 times 1 gives me 3. So my total below isn't 6 plus 1 anymore. It's 6 plus 3, which is 9. And now I want to try to balance 9 on this side. Ugh, it's a 2. It's an even number. How am I going to make 9 into an even number? This is our third trick for this lesson. We're going to do it with a fraction, 9 over 2. But the easiest thing to do is just remember that you're going to multiply everything times 2. Everything is going to get multiplied by 2. So the number that was here, 1, right? Because we didn't have to put anything there. So let's make sure that we now have 2 there. We want to have 9, so we balanced it with 9 over 2, right? Because 9 over 2 times 2 gives me 9, right? Remember, that's why we're using the fraction. 9 over 2, right? That's our fraction that we're balancing it, times 2, right? The 2 and the 2 cancel out. So we had a total of 9 before, right? So we had, if we're balancing it with the fraction here, 9 over 2, we would have had 9, which equaled the other side. But now 2 times 9 over 2, now our fraction becomes, it goes away. Now it's just 9 on the top. We're still multiplying through. 2 times 3, this coefficient becomes 6 now. And 2 times 3, this coefficient also becomes 6. Because it was already balanced with that fraction, 3 and 3, 6 and 6, 9 and 9, it's okay if you don't retotal. But if you want to retotal, this 3 is actually now 6. This 6 is actually now 12. And this 9 is actually now 18. This 3 became 6. This 6 became 12. And this 9 became 18. Because I have 2 times 3 is 6. 2 times 6 is 12 hydrogens. 9 times 2 is 18 oxygens. 6 times 1 is 6 carbons. 6 times 2 is 12 hydrogens. And now 6, my new oxygen total, 6 times 2, this one is 12. And 6 times 1, this new total is 6. 12 plus 6 is 18. Whew, that was a lot of work. Okay, moving right along. CAs, OHs, Hs, and CNs. This is the one where we want to make sure that we move this into its new form, right? HOH, that's our trick. So now when we're counting, we have one OH and one H. You can pause it to make sure that your totals make sense. I want to balance the OHs, so I need 2 of them over here. Now I have 2 OHs and 2 Hs. My CNs don't match and my Hs don't match, so I'm going to put another 2 up here. Bum, 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 bum. Now I have 2 Hs and 2 CNs on the left as well. Again, you can put a 1 there if you want to balance it. Does not matter. Either one is fine. You can leave them blank or you can put it in. Both are correct. C's, H's, and O's. Whee! It's the fun one again. I've counted everything already, but I'm going to add up my O's specially. 2 plus 1. So I've got 2 plus 1 equals 3 oxygens. First carbons, 6 and 1. So I'm going to put a 6 there. It changes my C's to a 6, and it changes my oxygens. 6 times 2 is now 12. 12 plus 1. So that means we have 13. H's, I want 14, so I'm going to put a 7 here because 7 times 2 is 14. 14. And it changes my oxygens. 7 times 1 is now 7. 12 plus 7 is 19. Whee! So now I'm going to balance the oxygens with 19 over 2, right? That's my trick for the fractions. 19 over 2 times 2 gives me 19, and it matches the total. But I can't leave that fraction there, so everything gets multiplied by 2. Right? Remember, we are multiplying by 2. So that means that this one becomes 2. This one becomes 19, this one becomes 12, and this one becomes 14 because I multiplied everything by 2. If you want, you can update your totals so that it makes sense. That's fine. 6 became 12, 6 became 12, 14 became 8, and 19 became, let's see, 20, 38, right? 19 times 2 is 38. All right, moving on. Last one. ALs, BRs, Ks, and SO4s. Nothing's hiding. It's just using the family method. So I'm going to use 2 ALs. To balance a 2 on the right, I need 2 on the left. It switches the ALs to 2s, and it switches the BRs. 2 times 3 gives me 6. I need 6 BRs on the right, so I put a 6 here. Now I have 6 Ks, 6 BRs. On the bottom, now I have 6 on the right, 2 Ks on the left, so I need to put 3 here because 3 times 2 gives me 6. And I'm multiplying 3 times 1. There's just one SO4, so now I have 3 SO4s, and it balances. Yay! Do you have to put the 1? No. Can you put the 1? Yeah. All right. Good luck. Email them if you have questions.